Hi everyone. Welcome to join our CPR 2021 tutorial on adversarial machine learning in computer vision. My name is Qihan Xie, and I'm so fortunate to co-organize this tutorial with Xinyun Chen, Chaowei Xiao, Judy Hoffman, Visha Patel, Luca Canoni, Tom Goldstein, Matthias Niza, Raquel Otterson, Dan Song, Rama Chalapa, and Alan Yu. So before we get officially started, here are a few tips for you better to attend in this tutorial. The first is that we will be recording the whole event. So even if you miss some talks, do not be worried so much. And we will make the video public available on YouTube or other like the video platform. And during the tutorial, all audience should like muted by default. But during the QA session, we will unmute you to let you for asking questions for our speakers. And the third point is that do not turn on your video during the workshop because it may slow down the network bandwidth or cause some issues. So regarding for asking questions, we provide two ways to do so. The first is that you can directly ask your question on the Zoom. For example, like there is a chat button, so you can put whatever you want in this chat function of our Zoom. The second way is that you can use what we Slido. We already provided the link of Slido on our official website, so you can go to this website and put your questions there. And also because we're streaming this whole event on the YouTube, so you can also post your question on the YouTube chat part, and we will try to collect those questions and bring them to our speakers. Okay, so let's move to the main content of this tutorial. So first of all, we all know that deep learning is pretty successful in computer vision, right? For example, we have two very popular data sets for computer vision tasks. One is ImageNet data set for object classification, and another one is Pascal data set for object detection. And before deep learning and in those old days, these two data sets are extremely hard for computer vision researchers. For example, without deep learning on ImageNet, the best result that we can get is 74.2 top 5 accuracy. And for Pascal object detection data set, the best result we can get is 40.9 mean average precision. But with deep learning, everything gets changed. For ImageNet, the current state of art is around 98.7 top 5 accuracy, and for Pascal, the state of art is 90.5 mean average precision. So that's a huge improvement, right? But deep learning is not so perfect yet. They still have a lot of problems. The first well-known weakness is that they are vulnerable to adversarial attacks. It is worth knowing that adversarial attack not only can happen in the digital world, researchers also find that attacks can reliably for deep learning systems in the real world. And this is one part that will be covered in today's tutorial. Besides adversarial examples, deep learning models are so poorly generalized to images that are not well covered in their training data sets. For example, the challenging outdoor conditions such as fog, rain, and snow may cause troubles to self-driving cars, as they are not well covered in the current training data set. They're out of distribution samples. And also deep learning models are very sensitive to occlusion, which is a fundamental aspect of our natural world images. As shown in this example, like say, you can see a lot of cars, right? But deep learning model can only be able to detect 3 of them. And this is also one part will be covered by Professor Alan Yu in today's tutorial. Okay, so in today's tutorial, we get 10 lectures for on this problem from the perspective of adversarial machine learning. The first lecture in the morning will be provided by Xingyun Chen from UC Berkeley. She will provide a nice overview of adversarial attacks in computer vision. The second lecture will be covered by Xiaoyan Luo and Vishal Patel. They will be talking about adversarial attacks and defense for videos. And the third lecture will be covered by Professor Matthias Nezel. He will be talking about deepfake creation and detection. The first lecture will be talked about by Chao Weixiao, and he will be talking about 3D adversarial attacks. And in the afternoon session, the first talk will be delivered by Professor Tom Goldstein from UMD. He will be talking about poisoning attacks on computer vision models. And then Judy Hoffman will be talking about detecting reliable instance for learning. Then the lecture will be covered by myself. I will be talking about the benefit of using adversarial example for training your image classifiers. And then Professor Raquel Otterson will be talking about adversarial attacks and robustness for self-driving. Then Professor Luca Canoni will be talking about certifiably robust geometric perception for robots and autonomous vehicles. The last lecture will be covered by Professor Alan Yu, and he will be talking about the robust object detection and occlusion with composition networks.